Welcome to Antenna by Panda. Today I will be making dual band 3x5 elements Yagi. It's for 2 meters and 70 centimeters. So we just need to follow the measurement according to the diagram. For the materials we need 1 by 1/2 rectangular tube. So we need to measure the boom length and mark it with the placing of elements on the boom. So this is already prepared. As we can see, we have markings and the cutting hole which will accommodate our Yagi elements. So next step would be to fabricate the elements holder from 1/2 tubing, 1/2 aluminum tubing. So we need to cut this by 2 inches and split it halfway. So we will have a elements holder that will look like this after we cut the aluminum tube. So to do that, we need to cut it using our jigsaw, or in this case I'll be using the Dremel tool to make it quicker. Another thing we need to make is the bracket for gamma match. We need to prepare it using a 4x2 aluminum tube and measure it according to the length of the bracket. So I already put markings on this. This is ready for cutting. We need to cut it about 1 inch, then bore a hole on the aluminum. It is preferable to drill a hole before you cut the bracket so that it will not bend. So let's do the cutting of the elements holder. After cutting the one side, we need to rotate it and clamp. As we can see here, we have the markings of the needle. So we just need to cut it again. Oops. So once we are done with cutting, I should wear the gloves because it's still hot. will split the aluminum tube in two. Like that, and this will serve as our elements holder. Our next step would be to cut the hole on the bracket. So now let's check the SO239 if it would fit on the mounting hole. So as we can see here, it's perfect fit. After we cut it, then it will serve as our bracket. Our next step is to cut the material for our bracket. The next steps for us is to taper the edge of the element holder. Same with the bracket for the gamma match. Once we are done with that, we are ready to mark this for mounting. We will now mark this elements holder for drilling. We also need to mark the bracket and put a center mark before drilling. these holes will serve as our mounting for the rivets on the boom. So we have to do the same on the elements holder. We have to drill those holes and attach it to the boom. Our next step is to attach the gamma bracket to the boom. So we need to drill holes on those mark points to attach the bracket. So once we are done with that, we have a nicely done bracket which can accommodate our SO239. This will serve as our feed point for the antenna. After attaching the bracket, we are now ready to attach the element holder. So once we are done attaching those elements holder, we are now ready to cut hole on those holders to accommodate our elements. As we can see, those element holders are now marked for cutting. So let's cut the mounting holes for those elements. So once we are done with cutting the mounting holes, we need to put a thread on those element holder. So we will be using a top bits to put a thread for the screw on the mounting holes. So once we are done with this cutting, we are now ready to cut the elements and drill holes on those so that we can attach it on the antenna boom. After putting up the hole on those element holder, our next step would be to cut the aluminum tube according to our diagram. So we just follow those cutting guides. I just proceeded and cut those using tube cutter and already marked the center marks on those aluminum tubes, and it's ready for cutting or putting holes so that we can attach it on the boom using these 3mm screws. So we just go ahead and cut holes on those elements. Once we are done with cutting those holes, we need to put a thread on those using the top bits. So once we are done cutting those threads, we are now ready to attach the elements on the boom. So once we are done with attaching the elements, we now have a good looking antenna. We just need to attach the gamma match. Next step for us is to build the gamma match using solid wire number 12, rubber stoppers, and a piece of aluminum tube. So we already measured this to be our gamma tube. So the UHF part is 3.5 inches. The VHF part is 7.5 inches. So I need to cut this. Using tube cutter. What we need to do next is put the rubber stopper at the end of the gamma tube. So once the rubber is in place, we are ready to put the gamma insert. Inside this. So that makes our gamma match watertight. I'm doing the gamma match for UHF. So this is 3.5 inches. So we need to measure the placement of the spacer. So we need to put it in the middle. So we have a gap of about 1 centimeter. So we insert the gamma spacer. It's from the RG8 coaxial cable, the plastic part. So we need to secure this with tape so that it won't move. So once that is secure, we can put it inside the gamma tube, and we need to secure the bottom part with another rubber stopper. So we need to cut hole on this and insert it on the wire, and of course secure it with tweezer. Once that is done, it makes our gamma match stable and watertight. So next step would be to do this with the VHF side and secure it with shrinkable tube. So we can see it's very stable. So let's do it with the VHF side, then let's solder this on SO239 connector. So now we need to solder this gamma match to the SO239 connector, but we need to taper this a bit so that it will fit on the center, then put a solder on it. So that's what we are going to do now. So we are now ready to solder this SO239. Make sure that we put a shrinkable tube. So after soldering, we can move it down and secure the part. So once we are done with soldering, let's focus make sure that the solder is clean, and we can now secure it with the shrinkable tube we put on top. Do the same on the upper part, then let it cool down. So once we are done with soldering, we are now ready to put it on the antenna. And we just need to attach the pacing harness and it's ready for testing. So let's do that. So our final step is to make the tuning stub. So we just need to cut 1 centimeter. Piece of aluminum scrap. This is from the boom. you can see here, this is our piece of boom. So we need to cut 1 centimeter thick portion of the boom, then drill a hole at the middle. For the aluminum strip, we need to use the aluminum plate and cut 1 centimeter, then bend it over the gamma match and the driven element. So what we need to do now is to secure the tuning stub on the gamma match and put the pacing harness, and it's ready for testing. So this time we are ready to test our 3x5 dual band element Yagi. So it's now connected with the pacing harness on the coaxial cable and the antenna analyzer. So as we can see here, we have the tuning stub, the feed point for the VHF, and the feed point for the UHF. So it's now connected to antenna analyzer. So let's check the frequency response of this antenna on 145. So as we can see here, from 145 we have 1.0 SWR, almost 1.1 at 46 ohms. We have the S11 or antenna reflection coefficient at minus 27 or 28 dB. So this is the BSWR curve. As we can see here, we have 1.8 SWR. So the lowest would be, that's at 145, it's 1.076 at 145. So the lowest would be around 144,900 or something. So let's check that. Move the dial to, as we can see here, we have so that's the lowest point. It's 144.6 at 1.045. So at around 145, we have 1.072. So that's the BSWR curve. We have less than 1.5:1 SWR from 142 to 148. So let's move the cursor to S11 curve. So let's check the S11. That's the impedance at almost 50 ohms. That's the S11 curve. We have the lowest point, of course, is 144 600 or 700 minus 32 or 33.83 dB or 31.66 dB. It's fluctuating, so it's around 32 or 30 dB S11 or antenna reflection coefficient. So let's check the UHF side. So let's start from 435. To 445. So from 435 we have 1.4 going up to 436, 437, 438, 439, 440 is 1.2, 441, 442, 443, and 444 and 445. It's 1.6. So let's check the VSWR curve from 435 to 445. So let's adjust the antenna analyzer. Set the limit first, the upper limit. For 5, lower limit is 4. .435. So we have 435 to 445. Switch to our SWR curve. So our VSWR curve on UHF frequency is less than 1.6 from 435 to 445. So let's check that. Going down to 435, we have 1.4, 436 is 1.5, 437 is 1.5, 438 is 1.4, 439 is 1.3, 440 is 1.2, 441 is 1.2, 442 is 1.4, 443 is 1.6, 444 is 1.7, 445 is 1.7. So this is a working antenna for VHF dual band. VHF UHF dual band, and let's check again the SWR on 145. So as we can see here, we have 1.0, 145, to 148, it's 1.3, going down to 142, it's 1.5. So we have a working antenna for 2 meters and 70 centimeters, which is a Yagi dual band antenna, 3 element VHF, 5 element UHF, with good antenna reflection coefficient of around 30 dB on VHF. And let's recheck the UHF S11. We have 20 minus 20 dB S11 carb on UHF. So thank you very much for watching. I hope you enjoy the building video of the 3x5 element Yagi. Until next time, cheers.